Hey everyone, welcome to this session. We're still discussing about the simple cell. So far in our previous video, we're discussing about the total voltage in these cells in power and in series. So today, let's move on to the other part where we'll be discussing about the cell defects. The cell defects here we're talking about the various uh, problems that a cell might face, or some situations that can hinder the proper functioning or the use of the cells or the simple cell. Now we have to note that the simple cell has two main defects, which they cause the current to diminish quickly when the cell is being used. Now these two defects of simple cell, they include as follows. The first one is the polarization, and the second one is the local action. So we'll be discussing each one of them, starting with the first one, the polarization. In terms of definition, the polarization, this is the defect that occurs in simple cell that is caused by the formation of the hydrogen bubbles around the copper plate. So this is kind of a defect that occurs in simple cell whereby these hydrogen bubbles are formed around the copper plate. Now, in such case, they hinder the proper functioning or use of this simple cell. These bubbles simply they insulate the copper plate and they prevent the other positive hydrogen ions from receiving electrons from the copper plate to become neutral. Now, also the hydrogen ions accumulating at the copper plate repels other hydrogen ions. This defect is called the back EMF and opposes or weakens the main EMF of the cell. Now, as you can see from such explanations, so the depositions of those hydrogen bubbles around the copper plate causing uh, the the repairing, and the repairing, yes, it affects the flow and the use or the construction or making use of this simple cell. So I hope that is very much likely clear. Now, let's see how you can minimize this kind of a problem, how to minimize the polarization. The polarization can be minimized by simply using suitable oxidizing agents called the depolarizers, just to remove the hydrogen. So when you remove the hydrogen, it will be likely the problem solved of this polarization. So the use of depolarizers or these depolarizers that are the suitable oxidizing agents will help to remove the hydrogen and they help to remove the problem of the polarization. An example of the depolarizers for the hydrogen is the potassium dichromate, and the dichromate oxidizes the hydrogen to form the water. So that's how it works, this potassium dichromate. So this potassium dichromate when it is infused in the hydrogen that is deposited within the copper plates, it oxidizes the hydrogen to form the water, and hereby the hydrogen is removed, and hence uh, the simple cell is ready to be used uh, very likely normally. Now, let's move on to the second defect, that is the local action. The local action simply it refers, or it's just simply is the process by which a cell is used when uh, no external current is flowing. Uh, so local action is just the kind of a defect that occur in a cell occurring when there's no external current that is flowing throughout the cell. Conventional zinc normally contains the atoms of the iron, lead, carbon, called the impurities. Now, when the conventional zinc is used in the simple cell, the bubbles of the hydrogen are the ones that are seen escaping from the zinc plate, evidence of the kind of the local action. So that's how illustrates the local action, how it might occur in the simple cell. Now, the impurities on the surface of the zinc act as the second plate of the cell. Now, as a result, the zinc dissolves in the acid even when the cell is not in use. Now, this kind of a process wastes the zinc, and hereby we get that problem, the local action. Now, how you can minimize this? Simply, the problem of local action can be overcome by simply using the agama, this amalgamated as zinc plate, that is the zinc coated with mercury. I don't know how to pronounce this one, whatever it is. Now the pure zinc is in mercury form, the zinc amalgam. Now that pure zinc, the one that is there. Now this is done by simply rubbing some mercury on the zinc plate. So that's simply how you can remove this local action. So by simply using this kind of a zinc plate that is coated with mercury, namely like this. So that's all I have for this kind of a session. We've talked about these defects of the simple cell. We've seen that there are two of them, the polarization and the other one, that is the local action. We've seen their definition, how you can overcome them, or simply how you can minimize them. Thank you.